All right. Uh, Last of these little PEMDAS by hand. At least I think it's the last. This is all I have on my mind on my schedule. All right. So we're going to look at square roots, and we're also going to look at these absolute value symbols in general. You could call these grouping terms, grouping symbols, that kind of thing. Uh, anyway, the idea is that they are going to act. They're going to act just like parentheses do, in that you have to do whatever's inside of them first. Except that you know what square roots do. They actually do something, whereas parentheses don't really do stuff, and you probably even know what absolute values do. But anyway, the idea is, well, we're going to do an example. You got to do those first, though. So in this expression, I've got -3 multiplied by all of this stuff. So after I figure out the answer for all of this, then I'm going to times it by this -3. All right, exponent first, that's going to become a 9. And then after I make that a 9, I'm going to multiply those two. That's going to be a 16. I'm going to do two steps at once here. So -3, that'll be a 9 plus 16. I got time. I can go ahead and add those. -3 times, that'll become a 25. All right, so now that I've done everything that's inside the square root, I actually have to evaluate the square root. All right, this is the part where the grouping symbol actually does something. So the square root of 25, that just asks, hey, what number do I have to multiply by itself to get 25? Well, 5 times 5 is equal to 25. So the square root of 25, this whole bit, is equal to 5. So you could write it in parentheses, or you can just say -3 times 5. It's kind of up to you, really. You can put it in parentheses if you want to. Just by way of example, in case you don't know your square roots, another example of a square root would be square root of 49. All right, that would equal 7, because 7 times 7 equals 49. All right. Hopefully you've done those before. I'm sure you have. And then the last thing is just multiply these. -3 times 5, that's equal to -15. Boom, we're done. That one's done. Stop staring at it. It's done. All right, I got two more here. If you want to give these a shot, you can. The absolute value bars, those straight up and down bars there, again, they're going to act like parentheses. But what you do at the end of the day, after you've done whatever whatever is inside the parentheses or whatever is inside the bars, then you're going to make sure that your answer is positive. That's what absolute value bars do. They take whatever is inside of them and they turn it positive. Now, be careful. Like a lot of people, whenever they see this problem here, they would just automatically make the 4 positive. They think, oh, this thing, this is equal to +4 plus 9, but it's not. All right, that's not the way these work. Like you don't get to say, oh, this is the same as -4 in absolute value bars and the 9 in absolute value bars. That's not true. Not the way it works. So we got to combine those, which is equal to +5. All right. And the absolute value of +5 is still +5. All right. Doesn't change to a negative for some reason. All right. So our final answer here would be +5. So the absolute value just means how far the number is from 0, and the number 5 is 5 units from 0. That's why the answer is 5. All right, let's go over here. So we got to do 7 times 2 first. So it's 2, and then 3 minus 14. And then we got to do 3 minus 14 next. Got to finish off what is inside the absolute value bars. 3 minus 14, that is negative 11. But now we're going to make it, all right, now that we got it narrowed down to just one number, now we're going to get to turn it to a positive value. All right, so absolute value of negative 11 becomes positive 11. I know I'm writing a bunch of stuff. You can do most of this in your head, but it's nice to be able to show your steps and all that. And then 2 times 11, that's 22. Cool. Got it. Last one. Yes, last one. All right. So this one's a little weird because we've got a negative on the outside. All that means, it's actually exactly like this. On this one, we waited until we got to the very end before we multiplied by 2. That's going to be the exact same thing we do here, except that we multiply it by a negative 1. All right. So inside the parentheses, inside the absolute value bars, we're going to do 3 to the third power first. That's 27. 3 times 3 times 3. Minus 20. Okay, so then this will be a 7. Negative. I know I'm writing this extra step here. I mean, this thing's already positive. I guess you don't really have to put this, but I'm putting it. Anyway, I evaluated what was inside the absolute values. That gave me 7. The next thing I would do is I would actually do the absolute value, which keeps it a 7. It's still going to be a 7. I'll write it in parentheses here because I've got this exponent hanging out. You'll see it actually doesn't even matter. But now at this point, let's see, what do we do first? We got to do the exponent and then multiply by this negative 1 or tack on the negative. All right, so this is going to be 49. So it's negative, and then you've got the 49. Hopefully that was some explanation. Hopefully you kind of see what happened there. All right. Good luck to you.